While trace points offer stability, they are static, meaning you can only observe events that kernel developers explicitly chose to expose. What if you need to observe a function or a specific instruction within the kernel that doesn't have a predefined trace point? This is where KProbes come into play. KProbes, or kernel probes, provide a powerful mechanism for dynamic instrumentation, allowing you to insert probe points almost anywhere in the kernel's execution path, even without recompiling or rebooting the system. They are invaluable for debugging obscure kernel issues, gathering custom performance metrics from specific kernel functions, or analyzing kernel behavior that isn't covered by existing trace points. KProbes can be placed at the entry of virtually any kernel function, KProbe, or at the return point of a function, KRetProbe, allowing for comprehensive monitoring of function arguments, return values, and execution duration. This flexibility makes them an indispensable tool for advanced kernel analysis.
The magic of KProbes lies in their ability to dynamically alter kernel code at runtime. When you register a KProbe at a specific address in the kernel, Perf or the KProbe subsystem first saves the original instruction at that address. Then it replaces that original instruction with a special trap instruction, often a breakpoint instruction like int3 on x86. When execution reaches this modified instruction, it triggers an exception, which the KProbe's handler intercepts. The handler then executes your custom pre_handler for KProbe or post_handler for KRetProbe, providing access to register states and memory. After your handler completes, the original instruction is executed and control is returned to the normal kernel flow, seamlessly resuming execution. This instruction patching is a sophisticated process, carefully designed to be atomic and reversible. However, this dynamic modification introduces a slightly higher overhead compared to static trace points and requires careful consideration of probe placement to avoid unintended side effects or system instability.